Okay, I want everybody look at this picture. Can we all see that these lines look parallel? Okay, unless they tell us they are, you can't assume them to be parallel. Okay, they do tell us the two lines are parallel, so they are. If that statement weren't there, you can't make the assumption. Well, they look parallel, so obviously they are. That's not allowed. Okay? So in geometry, you must be told lines are parallel. They're either going to tell it in the words, the lines are parallel, or they might mark it on the picture. If they do mark it on the picture, parallel markings are two bolded in arrows, like so, of the same type. That marking right there means lines are parallel. So if it looks like this, they're telling you they're parallel. If they use words to say it, the lines are parallel. Otherwise, you can't make the assumption that they are. Now in geometry, there's all these special names for these angles made when you can intersect parallel lines by a transversal. So first of all, let me get a little vocabulary out to you. This line here that's intersecting the two parallel lines is called a transversal. That's just the word that means that thing. So if I ever refer to a transversal, the generic name of a transversal is any line that intersects two other lines. That's what a transversal is. But the only place that there's any properties associated with it is when transversals cut through parallel lines. So typically, when you have math teachers talking about transversals, it's going to be in the context of a parallel line problem. All right. Now, there are all these special names for these angles. There's alternate interior angles, there's alternate exterior angles, there's corresponding angles, there's consecutive interior angles, consecutive exterior angles, all these special names that have all these special properties. This class isn't about understanding the abstract of geometry, it's about understanding the mechanics of geometry. So what I want you to understand about this, when you have parallel lines cut by a transversal, you get exactly two angle measures. Okay? Don't worry about the vocabulary. The transversal is the only vocabulary word you really need to know here. What I want you to know is you always get an acute measure, acute meaning less than 90 degrees, and you get an obtuse measure greater than 90 degrees. The only exception would be if you have a perpendicular line. If this is straight up and down at a 90-degree angle, they're all 90. Okay? So they're either all 90, or you get one less than 90, one bigger than 90. Two angle measures. But you get 8 angles. So what I want you to recognize here is this. When you see parallel lines cut by transversal, the acutes, the easiest way to describe acute is this. This is a 90-degree angle, goes smaller. Obtuse, this is a 90-degree angle, go bigger. All right. So if you take a look at the picture, there's 90, less than 90. Obviously 70 is less than 90. We can see the number, right? But just looking at the picture, I'm looking at less than 90, right? So the acutes, that one's acute, that one's acute, that one's acute, that one's acute. All the acute measures are the same. So acute equals acute. So where they tell me to find the measures of P, Q, R, S, T, U, and V, measure of angle P equals measure of angle Q equals measure of angle R equals measure of angle S. Measure of angle T, measure of angle U, and measure of angle V. Because you guys care about me so much also, let me just say this, for the sake of my grading of the homework. When you're asked to list a whole bunch of answers of a whole bunch of letters, if you put a box like that and put them all in alphabetical order, because that's what my answer key looks like, that'd be amazing. Be the best people ever. So alphabetical order, just a nice little box with all your answers. Show your work all over here as much as you want, but just record your answers in a nice little box in alphabetical order, so I can just compare them straight down. It'll be great. So all the acutes are the same measure. So R is acute, R is 70. S and V are acute, so S and V are both 70. There's no work to show there, it's just a matter of saying, hey, that's 70, so they're all 70. Okay, the other 4 angles are all obtuse. So P and Q and T and U are all obtuse angles. And the obtuse angles, oops, it's supposed to be a blue marker. All the obtuses are equal to all the other obtuses, right? But you'll notice that none of the obtuses are known, right? They don't tell us what the obtuse value is. All we know is the acute value. So the third relationship that you need to know is that acute plus obtuse equals 180. And again, there's all these special names of all these types of angles, and if I talked about alternate interior angles, I'd say they're equal to each other. If I said consecutive interior angles, they add up to 180. But the overall guts of every part of this is these three pieces of information. All the acutes are equal, all the obtuses are equal, one of each add up to 180. So, I know the acute measures 70, so I know that 70 plus one of the obtuses, I'll say P, is equal to 180 based on that fact. One acute plus one obtuse equals 180. If I solve for this, I move the 70 over, I get P is equal to 110. So now I know the acute of the obtuse measure is 110 degrees. So P is 110. All the rest of the angles, Q, T, and U, are also obtuse, so they're also 110. So 110, 110, and 110. Right. This is a little bit of work I'd expect to see. I want to see where you worked out and use this relationship to make the equation. The main thing about geometry at this level is none of these properties are very difficult, but there's lots of them. So if you're applying the property, showing your work in the application of the property, you're more likely to remember that stuff throughout as we learn more and more and more things. So apply a rule, make an equation, solve the equation if necessary. If the rules things are equal and you see that's that, then just write it down. But if you have to work stuff out, please work it out.